Hi students, it's Ms. Philippus. We will be taking notes on section 1.3 entitled Collinearity, Betweenness, and Assumptions. Our essential question today is a long one. It covers how can I recognize collinear and non-collinear points, betweenness of points, that each side of a triangle is shorter than the sum of the other two sides, and interpret geometric designs correctly. So you can pause this and write it down. So after you write your essential question, you're going to go over 2 or 3 fingers from the red line on your paper, and you're going to draw a vertical line all the way down. Remember, the left side we are going to leave blank, the left side of the line. We're going to reserve this for questions. If you run across any questions as you are taking these notes, you can put them here. We also call those points of confusion, or POCs. Points of confusion. So if there's anything that is not making sense to you, stop the video and just put a little question in the left column so you'll remember to ask. So what I want you to do now is I want you to pause the video, and either on the left page next to this right page or somewhere on the right side of the line that you just drew, I want you to draw 3 points. And then press play when you're done. There are 2 ways you could have drawn your 3 points. If you connect your 3 points, they will either form a triangle or a straight line. So if you drew your points like this, if I try to connect these 3 points, it's going to look like a triangle. The other way you could have drawn your 3 points is kind of in a line. And if you connect those, it looks like a line segment. So depending on how you drew your 3 points is how the points are related. So first of all, let's go ahead and label our 3 points. So I want you to draw whichever diagram you do not have. You'll either have a triangle or a line. Draw the other one. On the triangle, let's label our points A, B, and C. On the line, let's label our points, let's call them C, D, and E, or D, E, and F. It doesn't really matter. Try that again. D, E, and F. Okay, so let's talk about the points that form a triangle when I connect them. These are said to be non-collinear, which means they do not form a straight line. The opposite of non-collinear is collinear, which is how my points D, E, and F look. They form a line. So I'm going to pause real quick and write what these are. So the points that form the triangle, A, B, and C, are non-collinear points. They do not coexist in a line. If you really want to break down, not coexist in a line. Whereas on the other side, D, E, and F are collinear points. They coexist in a line. Okay? So let's go back to the triangle. So we're going to talk about it for a minute, and then we'll go back to the collinear points. We can also say that point B is not between points A and C. For it to be between, it would need to be on the same line or the same segment as A and C. If we look at D, E, and F, we can say that point E is between D and F because it's on the same line. So B is not between A and C because they are non-collinear. E is between D and F because they are all collinear. We can further make a statement that says, if I look at these smaller segments that are formed, I've got segment AB, segment BC, and segment AC. There is a theorem that says if I add two sides, any two sides of a triangle, it will always be greater than the third side. So the way that I would write this in symbols, I could say the length of AB, and if I take the segment line off of AB, that actually represents the distance between points A and B. So the length AB plus the length of BC will always be greater than that third side, the length of AC. And I can actually do this with any of the two sides of my triangle. I could say the length of BC plus the length of AC is always bigger than AB. I could also say the length of AC plus the length of AB is always bigger than BC. If I look at the collinear side, at the segments that it makes up, or that it's composed of, we have DE, EF, and then we have DF, which is the combination of DE and EF. If I add the length between D and E, which is called DE, plus the length between E and F, which is called EF, it will equal exactly DF, the entire length between D and F. To put this into words, the inequality on the left says that the sum of any two sides of a triangle, and I'm going to use the triangle symbol, is always greater than remember this is the greater than symbol, the third side. So this is true for any triangle. If you add any two sides of any triangle, it'll always be greater than the third side. The other one on the right is just saying that, if we have a segment, if I break it into smaller segments, the two smaller segments that make up the larger segment will always add up to exactly the length of the larger segment. In this class, there are lots of pictures, and from the pictures, there are things that are safe to assume about the pictures, and assuming means that we can say is true about them, and there are things that we never want to assume. So we're going to just make a list of that, and we'll practice this as we see more pictures throughout the class. So things that are safe to assume, and things that we do not want to assume. They will get you in trouble, and they'll mess you up. Okay, so let's talk about what's safe to assume. We can assume that we have straight lines and angles. So if you see a line that is straight, you can say it's a straight angle, it equals 180 degrees. We can also assume collinearity of points. So if we see a line and there are points on the line, we can say that they are collinear. We can make that assumption. We can also assume betweenness of points. On the collinear example with D, E, and F, E was between D and F because they were collinear on the same line or line segment. And then the last thing we can always assume is relative positions of points. Relative position is how something or where something is located related to something else. So, for example, in our drawings that we did on the other page, D was to the left of E and F. That's how the position of the points relate to one another. F is to the right of E, E is to the right of D. So that's relative position. So there's not a whole lot we can assume. Now there's a whole lot we cannot assume, and sometimes students get into trouble because they assume the wrong things. For example, you might have remembered this one from junior high. Never assume that you have a right angle. Just because a picture looks like a right angle doesn't mean that it is. You have to either be told, hey, that angle equals 90 degrees, or there has to be the little box in the corner. Some of y'all have seen this little box. That means you have a right angle. So never assume a right angle unless you have this little box guy right here. This guy right there. Okay? Another thing that you never want to assume is that segments or angles are congruent. They must be shown with ticks, tick marks, or arcs, or be told, or you must be told. Never assume that segments or angles are congruent. I'm going to use the angle symbol. And I'm going to use the congruent symbol because we got to practice our symbols. So we'll say, unless there are the tick marks, like we learned in the last set of notes, or the arcs that indicate that angles are congruent. And then the last thing we never want to assume is relative sizes of angles and segments. This is a big one. Let me show you real quick and then we'll write it down. So for example, if you see an angle like that and an angle like that, you cannot assume that the one on the left is smaller than the angle on the right, even though it looks that way. We cannot assume size. Okay? So never assume relative sizes. Relative just means how one size relates to another image. Relative sizes of angles or segments. Some of you also might have heard your teachers say that pictures are never drawn to scale. If they're on a coordinate grid and the scale on the X and Y axes are the same, they are drawn to scale. Otherwise, we never want to assume. Here's what I mean by that. So if I have an angle like this and it's for a particular problem, you can't get out your protractor and measure the size of this angle. Okay, you can't do that. They're not drawn to scale. Same with a segment. I could draw a segment this long and say it's 50 miles. If I got out a ruler, it might be an inch or might be a centimeter. We don't draw things to scale. You have to go by the information given in the problem. Okay, that's it. Write down any questions you have. Be sure to ask me next class.